Good afternoon. I'm glad to see still the room pretty full after this intensive day. It's a pleasure to be here to make a presentation of really a new evolution which has been done on a gas chromatography phase product. I know that most of you are considering gas chromatograph more or less a commodity, a black box where you shut the samples, and then you pay a lot of attention to the mass spectrometer side or to the sample preparation side, which is pretty important in your workflow. But from a manufacturing standpoint, from a technological standpoint, a company like Thermo has developed and invested a lot of energy to design a completely new platform. And what we have introduced this year at Pitkin just 1 month ago, and we are, of course, now bringing in all the exhibitions and events around the world, is really a completely new platform, completely new gas chromatograph. This is not something like equipment where we are changing a little bit something where here in the electronics, in the pneumatics, this is a completely renewed instruments. The only things we have kept on these instruments compared to the current platform is the PTV injector, because we consider the current PTV injector used on the Trace GC Ultra really a state-of-the-art type of injector. So this is the only part of the equipment which has been kept as it was in the previous equipment. All the rest of the equipment has been completely redesigned in order to increase the versatility of the instruments, flexibility, increase ease of use of the instruments, of course, bringing the performance to a new level, extremely reduce the bench space of the instruments, which is quite important in some routine laboratory, increase enormously reliability and uptime, and but again, the main key is the versatility and the flexibility. We introduced with these instruments a new concept around injectors and detector design. So all the injectors and detectors has been scaled down in size and miniaturized, in other words. All the electronics has been miniaturized in order to incorporate electronics, injectors, and detector in the modules which can be plug in and plug out by the users directly on the instruments. And this is the major evolution and innovation that we have introduced with these instruments. So when I've been invited to deliver this talk, I thought what was the key elements on a new product like that to be delivered to a platea like this one, which is mainly interested in the analytical aspect of PCB and dioxin analysis. So I extracted a couple of elements of these new products that I would like to introduce to you today. So mainly, what is this new modular approach on GC instrumentation? What is the benefit we are able to deliver to the laboratory thanks to this new modularity concept? The new injector design, a robust injector design which is offered by this new platform, which of course is, let's say, going into the directions to allow the users to reduce the sample preparation steps, to introduce a little bit more dirty samples without destroy the complete injectors. And we have brought in these instruments the backflash of the injectors as a standard solutions. And then a few conclusions. So let's start with the basic concept of modularity. I believe most of you are familiar with the classical concept of the gas chromatograph. Gas chromatograph used to have injectors on the top parts, detectors on the top parts. Then there is a line which connects injectors and detector bodies to the pneumatic controls. We need pneumatic controls in order to deliver carrier gas or detector gases precisely to the injectors and detectors. And then we have the electronic control boards located somewhere in the site of the GC. So if you are taking all the GC, whatever brand you have in your laboratory nowadays, and look carefully how it is built up, they are more or less built up following this concept. Analytical part, injectors and detector on the top, pneumatic control to the back somewhere, and then electronics boards on the side. Of course, from a manufacturing standpoint, this plays some constraints. The biggest constraints is that all the manufacturing are building up the GC according to the customer order. If you want an SSL with an ECD detector, we need to have an SSL and an ECD detector on top of the instrument, test the units, and ship out the instrument. So there is some logistic constraints around that. What we did with the new GC, we have taken electronics, the pneumatics, we have miniaturized them, we have redesigned injectors and detector, and we have incorporated all of them in a, let's say, handle modules, which has been made available as an independent part of the instruments. So when I'm saying a modules, I'm saying something like that. This is, for instance, is a speedless injector, which include all the pneumatics, all the electronics, and is a modules which is available to the user to be plugged into the instruments when it is needed and plug out when it's not any longer needed. So that means that you have a mainframe, which is a box, and on this mainframe you can plug in and plug out injectors and detector as it is needed. So this is the innovation we have brought with these instruments. Let's go into some details. Of course, with this concept of modularity, we have tried to build up into the GC the same kind of modularity which is delivered by the HPLC, where you have different modules of valves, different detectors, and you put together valves and detector in order to build up your analytical systems, whatever the application requires. If you have urgent application to be developed, you build up your analytical systems to satisfy your application, and you change the day after for another applications. That is exactly the same we did with the Trace 1300. This kind of modularity is patented. We call instant connect modularity. Again, is accessible to users, and it permits each modules to be installed in 2 minutes. There are 3 screws that needs to be replaced, and once you remove these screws, these modules is, let's say, unplugged from the pneumatics supply, and once you replace the next modules with these 3 screws, you are making the leak tightness to the mainframe of the instruments. Now, let's go with the challenging part of this presentation. Let's try to start a video, if I'm able to. Okay, let's see. Oops, the wrong one. Okay, let's start again this one. Oops. Let's start. So this is the replacement of the injector and the plug-in of the new injectors. And this is the same for any injectors and for any detector. So what you are doing, you are switch off the units, of course unplug the columns from the oven, remove these 3 screws, replace the injectors, put a new one, fix the screws, connect the columns, and power up again. One of the consequences of the miniaturizations, of course, is that the thermal mass of each component is very low. So that means that when you are plugging an injector and a detector and set up a temperature of 250, it will take 3 minutes to get to 250 with the very low consumption of energy, of course. So when you power up the instruments and you set temperature of 250 for injectors and detector, the units will take 3 minutes to reach the steady conditions. That's again another benefit in terms of get the unit ready to start. As I was mentioning, this modularity is available without requiring any service engineer. Units is designed to accept up to 4 different modules, and you can place one module instead of the other. The way the modules are built up, they include all the electronics to be completely calibrated by themselves. So usually for standard application, when you replace a module with a new one, you don't need to make any recalibration of the system. And this is just an example of some of the replacements. We started here with a speedless FID. Every injectors and detector has its serial number, so we modify a speedless module, and we made this standard test with hydrocarbons, 10 injections, and we measure here in this case the retention times, and you can see the difference in retention times between the original speedless module and the new speedless module. Then we replace the FID, we shoot again the same standards, and these are the difference in retention times. Same for peak area. Again, we change the speedless module, we measure the peak area, these are the variation in peak area. We change the FID, 10 injection of the hydrocarbons, these are the variation in terms of peak area. Of course, depending on the application, but for standard application, you don't need to recalibrate the system. What are the advantages? What is the benefit that this kind of new approach can deliver to the laboratory? Of course, you can upgrade by yourself. You can upgrade by yourself a GC from single to multi-channel. This morning there was, I believe Jeff was mentioning, or Frank was mentioning, in time of crisis, your instruments don't need to be stopped, even for maintenance. What happens if you have a maintenance to the injector? You need to stop the units. In these cases, what you can do, you can replace a module with the other, and you can keep the unit up and running, getting the unit producing results in time of crisis. So you can postpone, for instance, routine maintenance, and there is a number of benefits through this new approach. Second part of the presentation is regarding injectors. We design injectors on these instruments, pay attention to the robustness of the system itself. So we have, of course, the standard speedless, the standard PTV. We are doing the full range of injection modes with those injectors. For the speedless, we redesigned completely the injectors in order to have a very cool head, have a very low temperature of the septum, so we are decreasing a lot the effect of septum bleeding to the columns. We extend the septum lifetime for higher productivity. We, of course, improve the temperature profile along the injector itself. The injector is completely speedless, completely tubing-free. That means that you can replace the septa without any tools, without any tubing. You can assess and replace the liner without any tools. Just removing the cap of the injector, and you can replace the liner without tools. So that is a tubing-free injector, patented as well. Another important improvements, we have decreased enormously the air diffusions into the system, so we have been able to extend the column lifetime, and of course we preserve the mass spectrometer sensitivity. We made standards available, 2 modules with backflash capability, and the backflash capability is incorporated into the modules. So that means that within the modules there is all the facility, the 3-way valves, the plumbing, and the connections to do the injection, the normal injection, and the backflash. And this is available both for the standard speed-speedless injector and for the standard PTV injector. As you probably are familiar, just a few details. We are using a T adapter which permits to connect the analytical columns, a pre-columns which connect to the injector and the backflash line. In case the modules is used as a standard speed-speedless or standard PTV, we just cap the backflash line, and the backflash line is maintained under pressure of carrier, a slow level of pressure of carrier, and you can use the modules as a standard speed-speedless or standard PTV. You are probably very familiar with backflash capability. The way the backflash is realized with these instruments is such that you have not, let's say, retention time shifting when you are moving, when you are setting your transfer time. Just to make things a little bit clear, you all are familiar that you introduce the sample at low temperature, for instance, into the PTV, and then you start heating up the PTV. From the time you start heating up, you transfer the components into the pre-columns, and we call this transfer time. You might decide how long take this transfer time, and how long you take the transfer time will set more or less the cut in the volatility of your elution out of the columns. This kind of arrangement is such that whatever transfer time you are changing, the retention time will not switch, will not move. So, for instance, these are examples of a tick collected using a transfer time of 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes, 8 minutes. Retention time do not switch. Of course, we extended backflash to the speed-speedless injector. This is an example of a very complex hydrocarbon mixer. It's a fuel for automotive purposes. There is an ASTM method which is measure the aromatics in fuels. Fuels, as you can imagine, is a very complex mix. And what this method is measuring is mainly benzene and toluene content in this fuel. And of course, what we did with that, we set the systems in order to get rid of most of the complex part of the samples, and the system was working in a routine labs in a very reliable way. So the advantages in these cases was a number. So we, of course, with the backflash, we're able to preserve the column lifetime. So we have shorter run times, a saving in run times. We might increase the sensitivity because we can reduce the dilution of the samples because we increase the robustness of the systems. We can extend the detector performances. So all those kinds of benefits might be provided by this backflash capability. The last things, the Trace 1300 is fully available with the whole range of mass spectrometers, starting from the single quad up to the more complex mass spectrometers from Thermo. And I believe I'm ready for questions.
So any question immediately?
You mean remove the modules or remove the injectors?
Right. You gave an example of actually putting one in with a fresh liner, say doing maintenance liner changing on the point you're removing. Could you take it out hot of the instrument immediately and put the other one in and start heating?
As I was mentioning, as you can see here, the thermal mass is really minimized in all these modules. So the time needed to cool down is very, very, very short. And is really not comparable with the existing system. So if you are using to measure the heating time and the cool down time of your current system, this is something which is totally different because we minimize that. Of course, the instruments, there is a number of information, of course, I skip because these are totally new instruments which deliver benefits in every part of the instruments. I would be glad to explain a little bit more on a separated part. But for instance, the instruments has been designed to make maintenance very, very simple, especially for people like you, which are doing dirty matrices analysis. For instance, on the spitless injector, there is a possibility to remove completely the injector body and put on a sonification bath in order to clean up in case it is needed. So that kind of arrangement has been implemented on these modules, which should deliver a benefit for laboratory doing dirty, real samples in a routine way.
Okay, if you have any other questions, feel free to talk to Fausto during the dinner.
Yeah, sure.
All right. Thank you.
Thank you.
Thank you very much.